Okay, so today it's about the chapter A for the plotting the spatial data. So it's a kind of a literally how we can try to create a map for the based on our to visualize our spatial data set. So that's the thing. So it's a quite simple chapter. It doesn't take too much time. At the same time, it doesn't have a very difficult kind complicated concepts because I'm gonna cover chapter 8 then. So okay. So 8.1 is a kind of every plot is a projection. That means we actually whenever we try to create the map, we always think about what's the projection that best to represent or visualize that map. So what is we already know is the world is round, but the plotting the device is the flat. So it is anytime we have to visualize, we have to think about how we can projecting it. So that's the kind of things we have to keep in mind. So when you're looking down here, actually this code actually create the what is these ones. So the first code in here, this one, actually about the we just flat our world globe map in a flat like a piece of paper. So that means assuming that we have a kind of a round actually Earth is a round surface, right? But the thing is like there is actually cylinder like this, and then what if we can project all of these rounding information into this roll of the cylinder as a we can just think about the paper, okay? And then that's the how that's the what it looked like this in the bottom ones, okay? So in the bottom one like this. So whenever we Earth surface like here, and then assuming that we can create the cylinder like a roll of the paper like this. And then what if we can projecting all of these things like rotating all of those globe, and then we will get these kind of things. That's the how a thing about the way we can project these things. That's the reason why when we looking at the South Pole in here, like this one is South Pole, right? Like Antarctica, yeah. So this one is actually kind of like very distorted, all of this paper, because when actually it looked like this, but whenever we projecting this one, to the keep rotating that sphere, it look like those trajectory actually look like this throughout the whole paper. That's the reason why we have this kind of a map when we try to projecting these globe things into the flat surface. Okay, this code actually shows about how those things can be done depending on the projection. So that's the kind of what is the projection is about. So like ellipsoidal kind of things into the Cartesian kind of a flat of paper. So whenever we create or visualize a map, the first thing we have to think about is how we have to use the projection to create the map. What's the projection that allows us to visualize the map? And then when we try to do the like left plot of this one is actually this one, the left plot one, this Cartesian one actually have a kind of a latitude and longitude, right? Like this kind of a grid. It does not show in here, but it is actually has a grid, like a latitude and longitude linearly kind of a projection. So whenever we testing those things in here, it says true, right? Like here. So it says about the true in here. So there's those kind of things is like a equi-rectangular kind of thing, like a equidistant cylindrical. That's the reason why I said this is the round, and then these are the cylinders, and then we project those things as a map, and then when we spread out that cylinder as a roll paper, we have the map, the plot on the left. And then move down here. It is also the same for the when we try to project some of the very small area like Germany, country map. We also try to do the same thing, like setting up the geometry in here, and then we can also define the projections. And then when we try to make a map, it looks like this, like a prob axis or true or not. So in the first one is a kind of a default value is a kind of like a Cartesian kind of a cylindrical kind of a projection, and then a second one is the kind of like another like a right one is a kind of a equicylindrical kind of one, like this kind of a large number actually says about the what is called the loading value. Is about the how north it is, degree of the how north it is. And then also there is another is the easting value. That is how east is, how extent of the how far away from to the east. This one is what is called a Cartesian, like a cylindrical based kind of approaches, like a node representing all of the coordinates based on the noding and then the easting kind of a coordination system. And then there is also another representing kind of like a actual kind of a longitude and latitude. And then this one is easting and loading. Okay. Is there any questions so far? Anything?
Yeah, that's interesting. So I'm interested on those things. Basically,
Yeah.
this UTM is the distance in meters of a particular location from the north, from the east side.
Yeah.
Yeah, so it's usually used for cases when you need a very precise location.
Yeah, it is a noding. Yeah, and then this one is a easting.
Yeah.
Yeah, so it's kind of how far away from the origin of the sphere, like the when we looking at when we looking at the Earth, there is a kind of origin in here, and then from here, how far like a Germany country actually located, like this.
Yeah, and more
then
specifically,
yeah.
and more specifically, they divide the Earth into zone, so that you can identify the zone number where your specific location is, and then that would be the point, the starting point to calculate the distance from the north.
Yeah, right. And then in the plot on the left, it is about the angle, like these things, like from here to the angle, and then angle up to the top, right? So this is what north and east come from, like east here, and then north in this angle and this angle, right? But this one is actually based on the cylindrical surface. So surface of the map from this one as the origin, and then how east as a meter, and then how north as a meter. There is a map. That's the difference. So right, plot on the right is the surface. Is based on the surface kind of a coordinate system, and then this one is actually more like a internal, inside kind of angle kind of things. What we actually know about the longitude and latitude. So this one is more like I think a Cartesian kind of a coordinate system. So that's the thing. Yeah.
This one, the long lat is it's general, always the same thing. So you know that this position belongs to a specific long lat value.
Yeah.
Why the here the UTM can repeat themselves, so you can have more than one location with same distances to specific points, for example.
Okay. Yeah.
So that's the distance from the in meters of your location identified on a Earth zone from the north and the east.
Yeah, right. So, and then next one is what is the good projection for the data set? Actually, it's listing about the three things, about the areas and directions and some property of the distances like a rectangle or those kind of things. Yeah, I think this one is a quite good good criteria that when we try to choose the projection. But the thing is that thankfully, unfortunately, actually, when we're looking at the ArcGIS or maybe when we're looking at the EPSG kind of informations, it already contains about all of these kind of information. And then the coordinate projection name, like a title or name, by itself already explain about a lot of things. So we just choosing about based on the what projection name is about, and then we can just feel free to choosing it. So actually, these are the very fundamental criteria when we try to looking at the good projection for our map data, our map. But the thing is, luckily we already have a projection name that explains by itself. So we just looking at the projection name, and then we can easily recognize what the projection is about, and then which part of the area can be best represented in that projections. So that's the thing. Actually, that's actually my own criteria about the things. Just looking at the projection name, and then to see what's the best one is about, depending on my spatial data set or map information. So, but these three is also very useful. So that's what is about the good projection, like areas and directions and some property of the distances, like is there an angle, like a degree, or is there kind of a meters, or is there kind of a mile? It is quite important to think about what's the basic unit of the depth projections, because based on those kind of things, whenever we learn some of the model or spatial data analysis, we have to interpret our result based on these spatial units. So these are the quite important property. Oh, whoops. And then let's move down to the 8.2. So now we actually talking about the plot, how we can plot the point and line and point one and cells. It is actually in here, like some challenges is a kind of a polygon may be small or this vanishes when plotted. It is if polygon is very small, maybe that cannot be directly appear into the map depending on what the scale is about. And then also depending on the data polygon can be overlap to one another. And also when you point in the plotted on the symbol, it is easy to overlap and then hidden. especially for the when we try to use the density map, like there is some of the polygon, and then there is a lot of point, and then at this point, maybe some point can be overlapped to one another. So those things actually this one is about. And then line can be hard to read because it's a line here, like a line with the, and then these kind of things is hard to read, but at least we can visualize it theoretically. And then when we choose about the choosing the color, so actually what is definitely the thing the R package is commonly used to the coloring is the R color brewer. This one is actually have a lot of different palettes. So depending on that, we can actually feel free to use those palettes to present some of the thematic attribute of the map. And OR abilities is also another thing, and then the color space. But I personally think that R color brewer and abilities is the ones commonly used for the coloring for the plot or map. So that's what I know. And then what is important about the coloring is how we can break the value, attribute value. So that's the kind of a very important part, because that actually determines about how we can color the map based on these breaks. So in case of those breaks, we actually use the called class int. It's a class interval. So this package actually allows us to break the value based on the whole different kind of method. Like in here, and when you're looking at the bottom in here, actually there is a several option. Like a fixed option is we can just dividing those break with the same interval, right? SD is a kind of like based on these kind of distributions, and then from the mean, one negative one standard deviation, one standard deviation, two standard deviation, negative two standard deviation. These are the kind of a breaking point of that we can use for the standard deviations, and also equal and pretty quantile. Pretty is a kind of like breaking the point, breaking the value based on the best visualization of the map. And quantile is like a first quantile, second quantile, like a median, and then a third quantile, fourth quantile, etc. K means clustering is like based on the clustering of the value, and then H clustering is a horizontal clustering value, and then a B cluster is, I think, is the binary. I'm not sure like a B stands for. Fisher and Jenks is another thing. Actually, when we use the ArcGIS, we actually used a lot of Jenks kind of breaking to visualizing the map. And then also another thing is the fixed or standard deviation, depending on our distribution of the value attribute that we wanted to present as a map. And also we can choosing the argument n for how many number of interval we're gonna use. So maybe 5 or 10 or 15, we can decide how many interval we have to set up. This one is how we can try to do the intent. And based on these kind of interval values, by using the R brewers, we can try to represent each color, assign each color to each specific range of the values. So that's the kind of thing. And then graphical and then other navigation aids is kind of like it is actually literally kind of the grid on the map. Like there is a map like this, and then this is the plot, and then the graphical means like this kind of like a grid, you know. So that represents about the latitude and longitude kind of grid. These are the kind of what is called the gratitude. So we also thinking about how we can define the color for the gratitude, because if Gradical is too stand out too much, we had to changing that color into the much lighter one, like a cool gray or some kind of a very transparent or transparent coloring, so that we can actually make our map much more stands out compared to the Gradical. That's the thing this one is talk about. And then 8.3 is about the base plot, like how we can flattening the map by using the very base R function called plot. So it is quite simple, because when we read the SF, like the simple features in here, and then we just simple using the plot like this, or maybe we can just plot and NC and bird 74. This by itself can be plotting the map. So all of the reset or key position is a kind of a very optional kind of argument. Just only using this one can be give us a map for that. And also this one is a ST buffer, means kind of like it just only try to do the buffering, make a buffer for this. I don't know why others can do that. But the thing is that, as you can see in the here, this one is the 1.1 kind of a county, and then it actually have a buffer for the 10 kilometer. In this case, it's a set unit is a 10 kilometer, right? So that is the make a buffer for the 10 kilometer away from the polygon. That's how this one is about. And then this one is a basic plot function using the base R to present visualizing the map. And then we can also using the plot function even if we have a last image like this. Whenever we have a deep kind of a LiDAR or satellite raster images, we can try to set up the box, and then I don't know why this kind of a function is things. I think that this one is actually function for the controlling some of the optional arguments into the one single functions, and then just plotting it as a raster images. So what this code is about is if we can actually using plot for the normal map and also raster images. So that outcome is actually at the bottom, and then we can also draw the circle based on these hook functions. And then these are the kind of things about the presenting the map by using the simple plot functions. And then we can also map with the ggplot2. ggplot2 actually have a lot of good visualization functions we already know about. So it is also applied to when we create a map. So like for example, by using some of the tidy model, tidy burst kind of a data things, we can clean up our data in here. And then when you go down here, the ggplot, we can using the parcel wrap function to buy the name, and then using this longer. The reason why we actually have this kind of longer table is actually when we looking at this NC32119 table, it actually have a name and SID 74, SID suicide rate is 79, etc. So actually these two are the separate column. What this one is about is we actually pivoting by using these two columns, because this one is actually right now is the wide format. But the thing is what this function does is we actually converting this wide format table into the long format. So now we have a kind of a name called as one is the SID 74, the other one is SID 79. This one is keep repeating across all of our county. So our county one has the two row right now. One is the SID 74, one is the SID 79. Because we actually converting the current wide format table is a longer table, long format table by using these two columns so that we can get the name. And then by using this name column, we can actually drawing this parcel lab mapping. So let me show you my R kind of plot. So like here. So but what this one does here is it says is in here when we try to pivot longer, and then when you're looking at the NC head NC 32119, and when we looking at the head NC longer, can you see that this text is a pretty small font size? So maybe
very small. Yeah. Very
let me make it bigger. Now you can see the font.
Yeah, a little bit better, but it's still too far.
Okay. How about this? Can you see the font?
Yeah, that's okay.
Okay. So when you're looking at the compare to the, maybe I might have a much bigger. Okay. And then let's see. Now you can see a little bit better, right?
Yeah.
Yeah. So the table at the top is this one is the original table. So as you can see here, when see at the bottom, when you're looking at the NC32119 table, it actually have a seed 974, seed 79. It's as a wide format. But in the pivot, by using the pivot longer options, we can actually converting that one as the name to the 74, 79. So that means each polygon has the two separate row that represents the seed 74 and 79. And then by using that one, when we create the plot, we will have this kind of a plot based by using the then name. Okay.
Yeah.
Yeah. So that's what I want to say about in here. And then let's see. And also, it is also same for the whenever we using the raster images, we can also use the same thing using the ggplot. And then it actually visualizing these raster images much better compared to the grayscale in the previous slides. Okay. So it's just kind of a matter of how you want to visualize the map by using what. Are you gonna use just a simply plot function in a base R, or maybe you can import the ggplot2 packages and then visualizing it. ggplot2 actually much better compared to the simple plot one, but it's up to you, and then it's up to how we can visualizing it. And then the other thing is the map with the T-map. Like there is also a package called the T-map, which is a more like a interactive mapping packages. So we can also use the same this one. But in this case, what is the good about this T-map is we do not have to worry about the changing the wide format table into the long format table. By using the T-map, actually each column can be visualized as a separate mapping, as you can see here at the column. So in the previous one, we actually converting our original data into the longer table, right? Because a facet lab argument in the ggplot only takes one single column as a categorical variable to represent the faceting the plot. But in case of the T-map, we can actually designate about the columns that include all of the attribute values that we wanted to visualize. And then by using designating these two columns, we can get the same result like this, right? This at the bottom. So what is the good thing about the T-map is we can actually use the wide format as they are, as it is. And then we just designate the column name that we want to represent into the plot. In case of the ggplot, if we have a wide format table, spatial data attribute table, we have to manually converting to the longer format from the wide format, and then visualizing the map based on the depth faceting function. But in case of the T-map, we can using the wide format spatial attribute table as it is, like this. So we get the same result, but the thing is the T-map is a little bit more convenient if we have a wide format spatial attribute table in this case. And then it is also the same for the raster images. Also, it's a very simple kind of a command, and we can actually do the raster images like this. And then in the 8.6 is about the last chapter one is about the map view and then the T-map functions. So it is more like an interactive mapping techniques. So it does not give us any kind of example in here. So I'm gonna try to show you how we can use those T-map and map view. So in here, we actually use the T-map, right? And then we can click this one, and then we only things about we just by generating the columns, we can actually presenting this kind of a plotting result, right? And also, when you changing the mode for the T-map as a view, it actually changing set to the interactive viewing, and then when you run this command again, we can see this kind of interactive functions like zoom in and zoom out, right? And then we can changing the layers like this. And then when you click all of these small ones, like polygons, we can see the data set, right? What the data set is about, right? So that's the thing. And then the other one that I wanted to talk about is how we can use the map view. Map view is the much more convenient one. So in this example, I actually using the census, US census data set, and then loading the census data. And then when we create the map view, like this, right? This one is a much better. Actually, map view provided a much better function compared to the T-map, because it also has many different kind of a background map. And then when you click these polygons, it actually give us a more like a range and organize the table information result. Look like this. Okay. So these are the kind of example of the map view. So what I wanted to tell you here is we can actually by using the map view or Tmap or leaflet, we can actually create one of the very interactive mapping with a widget in it compared to this kind of static plot. So these are the kind of how we can visualizing map and how we can make it much better based on the coloring and some other art packages. So I think that this is it. So